Hello family, before us we have question 12 from Mathematics paper 2 for the year 2024 for GCE. This question 12 is coming from section B of the same paper, and under the same question 12 we have two questions coming from two topics. The first topic we'll cover is under the eighth geometry. The second question will be under the mensuration. So let's begin with question A. The points P has 80 degrees north, 50 degrees west. So the first point is the latitude. The second one is the longitude. Q, 80 degrees north, 80 degrees east. So we have the first one, latitude. The second one, longitude. R, 50 degrees north, 80 degrees east. Latitude, longitude. And T, 50 degrees north, 50 degrees west, latitude, longitude, are on the surface of the Earth. Take pi to be 3.142 and radius as 6370 kilometers. Roman number 1, draw a sketch to represent the above information. So we are given points and we want to come up with a sketch to show how these points can be located. So the first one, you need to draw a circle. Here we have the north, south, west, east. Then I'm going to put a point here as my center, so just to guide me as I'm going to draw these points. So the first, let's look at point P. So point P has the latitude of 80 degrees north. So the latitude are imaginary lines that runs from west to east. Now since it's located north, it is going to be above this point. I'm just going to put it here. So this is our 80 degrees north, the longitude is 50 degrees west. So since it's west, I'm going to put it here. Now the point where the 80 degrees north intersect with the 50 degrees west is where our point P must be put. So this is our P. So we are done with the first point. We move on to Q. Q is 80 degrees north, the latitude. So we already have the 80 degrees north. No need of drawing another one, 80 degrees east. So this longitude is located east. Therefore, I'm going to draw a longitude on the east side of our Earth. So the intersection of these two lines here is where our Q must be written. We move on to R. R is 50 degrees north. Now since 50 degrees north is less than 80 degrees north, therefore this 50 degrees north will be closer to the point or to the equator. So that's what you're supposed to do. So the one with the greater number must be away. The one with the less number must be closer. So we are saying this is our 50 degrees north. Then we are told, 80 degrees east. We already have 80, so this point is where our R is. T is 50 degrees north. We already have that. 50 degrees west. We already have that. So this point is where our T is. So this is our answer for the first part. So let's hope we've made sense out of this information. We move on to Roman number 2. So here we need to do some calculations. Calculate the distance QR. So it's along the longitude. So whenever you are told to find the distance along the longitude, you need to find a difference in latitude. So if you look at Q, the latitude for Q is 80 degrees north. Then for R is 50 degrees north. So since they are all located on the northern party, we need to subtract. So to find the theta, I'm going to say 80 degrees subtracted by 50 degrees, giving me the difference of 30. So this is what you need to make sure you understand. So we can now look at the formula. So the formula is given by this: distance is equal to theta, which is the difference, over 360 to pi r. So if you want, you can use it direct, or if you want, you can say distance is equal to theta over, we know that 2 into 2 is 1, 2 into 360 will give us 180, then pi r. So if you use theta over 180 times pi r is same as theta over 360 times 2 pi r. So the answer will not change. Okay, so now let's do some substitution. Distance is equal to theta is the difference. So we have 30 over 360 times 2 times z. Pi is given 3.142 times the radius is 6370 kilometers. So at this point, I'm just going to do some calculation. 30 times 2 times 3.142 times 6370. Okay, divided by 360. So I'm finding my answer to be 3,335.75, which is 8 kilometers. So this is our final answer. Then you can take it to 3 significant figures. So let's move on to RT. So RT is along latitude. So what do you do? So whenever you're dealing with latitude, you need to add a cos x. So the formula is like this. You say distance is equal to 360. Not 360, sorry. Theta over 360 2 pi r. You put cos x. So x denotes the latitude where the two letters are. So since we want the distance along the latitude, we are supposed to find the difference in the longitude. So what is the longitude for R? Is this one, 80 degrees east, then 50 degrees west. Here we are going to add. So we say difference is equal to 15 plus 80. So this gives us 130. So we have 130 over 360 times 2 times 3.142 times radius 6370 cos. What are we supposed to put on the x is the latitude mentioned. So the latitude mentioned is 50 degrees north. So I'm just going to do the simple mathematics. 130 times 2 times 3.142 multiplied by 6370. Then we have cos 50 divided by 360. So according to my calculations, I'm getting, we have 9,291.45, which is 0.5 kilometers. So this is our final answer. We move on to question B. So question B, as I said earlier, it's coming from the topic of mensuration. So we are told the figure below is a frustum of a cone. The base radius is 2 centimeters. Top radius is r, and the height is 3.6 centimeters. Take pi as 3.142. Calculate the value of R if the height of the cone from which the frustum was made was 6 centimeters. So the first one that we are going to do is we need to complete this frustum as a cone before it was cut. So I'm going to draw a cone. So this cone that I've added on top is called the smaller cone. Then the whole cone is considered to be the larger cone. Now remember, the total height of the cone before it was made is given from the question 6 centimeters. So we have our 6 centimeters. So if we have the height of the bigger cone, we can find the height of the smaller cone. So the height of the smaller cone will just be the difference between 6 and 3.6. So we'll say 6 minus 3.6, I'm getting 2.4. So 2.4 is the height of the smaller cone. Now to find R, we are going to use the principle from similar figures. So I'm going to say height of the smaller cone divided by height of the larger cone is equal to radius of the smaller cone over radius of the larger cone. So height of the smaller cone is 2.4 divided by height of the larger cone is 6 is equal to radius of the smaller cone we don't have, radius of the larger cone is 2. So this is for the larger, this is for the smaller. Then we cross multiply. So 6 times R give us 6R. 2.4 times 2, I'm getting 4.8. So to solve for R, we divide by 6. We divide by 6. R is equal to, so I'm getting 0.8, and it's making sense because 0.8 is smaller than 2. Then for Roman number 2, we have the volume of the frustum. So let me write what I have here. So the information is the height of the smaller cone is 2.4. Then height of the larger cone is 6. Radius of the smaller cone 0.8. Radius of the larger cone is 2. So we can now find the volume of the frustum. So there are two ways in which we can find that answer. So the first one, I'm going to find the volume by finding the difference between the volume of the larger cone and the volume of the smaller cone. So you say volume is equal to, so we need to know that the volume is so for the larger cone will be 1 over 3 pi r squared h minus for the smaller one will be 1 over 3 pi r squared small letter h. So we can factorize. So if we factorize, volume is equal to, so 1 over 3 is common. What else is common? Pi. So if we open brackets, here we are going to have r squared h minus r squared h. So this is the formula that you are supposed to use. Now when using this one, make sure you have the radius for the smaller cone and the larger cone, the height for the smaller cone and the larger cone. So we can now say volume is equal to, so this same as pi over 3. So remember, pi is 3.142 over 3. Radius is 2. For the larger cone, it's 2 squared. The height is 6. Minus for the smaller cone, 0.8 squared. The height for the smaller cone is 2.4. Then at this point, I'm just going to do some math. So 2 times 2 is 4 times 6, 24. Then 0.8 squared, I'm getting 0.64 times 2.4, I'm getting 1.536. So 24 minus 1.536, I'm getting 22.464 multiply by 3.142, getting 70.58 divided by 3. So according to my calculations, volume is 23.5, so say centimeters cubed. So that is our final answer. Now to find in another way, so we can now go back to our structure. Now for the second one, no need of finding the height of the smaller cone, so we can just use the height of the first term, which is 3.6. So let's do some math. So what is the formula of the volume for the first term if you just want to go direct? So the formula will be volume is equal to, so we're going to have pi height over 3, then r squared plus small r squared, then plus r times r. So this is the one that you're supposed to use if you just want to go direct. So pi is 3.142, radius, height of this first term now 3.6 over 3. So r, what is our r? Is 2 squared plus 0.8 squared plus 2 times 0.8. So I'm going to say 3.142 times 3.6 divided by 3. So I'm getting here 3.7704. We move on to this point. We have 2 times 2 is 4. 4 plus 0.64 plus 2 times 0.8, I'm getting 1.6. So I'm going to say 1.6 plus 0.64 plus 4, I'm getting 6.24. Now to find the final answer, we can just multiply 6.24 times 3.7704. So I'm getting 23.56, which is 0.5 centimeters cubed. So as you can see, you are finding the same value. So if you are using this one, make sure you just use the height of the first term for this one. And this is very applicable in a point where you're just taught to find the volume of the first term. So you don't have to find the height of the smaller cone in case you are not given. So for such questions, this is a very applicable questions. So that's it for this video. Thanks for watching.